Okay, the time has finally come where we're going to talk about adding and subtracting fractions with uncommon denominators, or we could say adding and subtracting fractions with unlike denominators, okay? Or we could say adding and subtracting unlike fractions. There's different ways to say the same thing. Now, this is kind of what all of this has been leading up to the last few videos. So we're going to kind of just dive into it, but steps for adding and subtracting unlike fractions is to find the LCD. Remember, LCD stands for least common denominator. All right. And we learned in the last video that there are two ways that we can find a least common denominator. One is to list out a series of multiples of all of the denominators until you find one in common. The other method involved prime factorizations, and I'll try to do both. Okay. I may have to go to some scrap paper in order to do the steps, but we'll make it happen. Okay. So you find the least common denominator. Once you find the least common denominator, you find an equivalent form of each fraction using the LCD as the new denominator. So we've talked about equivalent fractions in a number of ways. So we're going to apply that again here. Once you have equivalent fractions where you have the same denominator, you add or subtract the numerators and then keep that common denominator. And then the very last thing you do is simplify. Okay. Now, for this first example, we have 9/10 minus 5/7. So I'm going to do the multiples method for finding the LCD. So generally speaking, you start with the larger denominator and you list out multiples. I think I have space here, so I'll just do this one in the body of the problem. So 10 times 1 is 10. 10 times 2 is 20. And then we get 30, 40, 50, 60, 70. A lot of you caught your breath there, but we'll get to it in a second. 80, 90, 100. We listed out several. Now we want to do the same thing for 7, the other denominator, and we're going to list out until we have one in common. We may have to keep listing, hopefully not. So 7 times 1 is 7. 7 times 2 is 14. Times 3 is 21. Times 4 is 28. Then we get 35. We get, let's see, 42, 49, 56, 63, and then finally 70. Ding, 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 ding. There we have it. So 70 is the first number or the first multiple these two denominators have in common. So the LCD is 70. All right. So step 2 of this process is to find equivalent forms of each fraction. Okay. So I'm going to show all the steps for this worksheet. In the future, sometimes we'll sort of condense steps or do things in a shorter way, but I want you to fully understand this. So we have 9/10. I want to rewrite that with 70 as the denominator. So what would I multiply 10 by to get 70? Well, I'd multiply by 7. And if I multiply the bottom by 7, I have to multiply the top by 7. Because remember, do you remember when we talked about equivalent fractions? You're multiplying by a weird form of 1. 7 divided by 7 just equals 1. When we multiply by 1, we don't change the value of what we started with. So it's just a weird way of multiplying by 1. Now, 9 times 7 is 63. Okay, we're going to do the same thing for the next fraction. We had 5/7. We want to rewrite that with 70 as the denominator. So what would I multiply 7 by to get 70? Well, I'd multiply by 10. So we're going to multiply top and bottom by 10. That's our weird form of 1 there. So 5 times 10 is 50. So what we're going to do is just rewrite the problem now, but we're going to plug in those equivalent forms of the fractions first. So I get 63/70 minus 50/70, and that's going to be 13/70. 13 is prime, and it is not a factor of 70, so we're done. Okay, so that's how you would do adding and subtracting fractions with different denominators. None of these individual steps are necessarily difficult. There's just a lot of them. That's the problem here. That's what people don't like. Okay. Now, next up, we have 5/8, 1/3, and 1/12. We need to find the LCD here. So I'm going to go ahead and do the prime factorization method. So 8 can be written as 2 times 4. 2 is prime, 4 is not. So I'm going to write 4 is 2 times 2. 3 is already prime, so there is no prime factorization of 3. It is what it is. And then 12, I'm going to write it as 4 times 2, or 4 times 3 rather. 4 is not prime, so I'm going to write 4 as 2 times 2, and then 3. And I think I have enough room to squeeze in the table here, so it might be a little scrunched, but I want to try to fit it here if I can. Remember, you want to have a row for each denominator, so we need a row for 8, 3, 12. We also need a row for the LCD. We're going to fill in the prime factorizations here. Remember, once a number's in a column, that is the only number that can go in that column. So I'm going to go ahead and fill in the factorization for 8. 8 was 2 times 2 times 2. So that means we've got a 2's column, a 2's column, and another 2's column. Now I need to fill in the factorization for 3. Since 3 is prime, it just is 3. Well, I can't put 3 in any of the 2's columns. I can't put it in the first, second, or third column because the only type of number that can go there is a 2, so I need to add a new column for the 3. All right. And then I want to fill in the factorization for 12. We want to fill in as many factors in the existing columns as possible. That gets rid of repeat. Okay, so for 12, I have a 2, I have another 2, and I have a 3. So luckily I didn't have to start any new columns. Now what you do is you bring down the representative from each column. The first column is a 2's column, so we bring down a 2. The next column we bring down a 2. The third column we bring down a 2. The fourth column we bring down a 3. And if we multiply all of those numbers together, that gives us the LCD. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So 24 becomes the LCD, okay? So now what we want to do is we want to rewrite all 3 of these fractions using 24 as the denominator. So I'm going to see if I can fit this in. So we have 5 over 8, but we want it to be something over 24. So we ask ourselves, what do I multiply 8 by to get 24? Well, I multiply it by 3. So top and bottom by 3, we get 15 24ths, okay? 1/3 needs to be rewritten with 24 as the denominator. So again, we ask ourselves, what would I multiply 3 by to get 24? I would multiply 3 by 8, so top and bottom by 8, and that gives me 8 24ths. So 8 24ths is equivalent to 1/3. It just has the right denominator. 15 24ths is equivalent to 5/8. It just has the right denominator. Finally, we want to take 1/12. What would I multiply 12 by to get 24? I would multiply it by 2, so top and bottom by 2, and I get 2 24ths, which is equivalent to 1/12. So I'm going to rewrite this problem using these new equivalent fractions. So we started out with 5/8, which is really 15 24ths. We subtracted 1/3, which is 8 24ths. We subtracted 1/12, which is 2 24ths. So this becomes 15 minus 8 minus 2 over 24. And then we just subtract left to right. So 15 minus 8 is 7. 7 minus 2 is 5. So we get 5 24ths. And that is simplified. That's your final answer. Okay? Now, the last 2 examples might be the ones that are maybe a little bit more difficult because they're mixed numbers. So do you remember in a previous example or a previous video, we talked about adding and subtracting mixed numbers? You can leave them as mixed numbers or you can write them as improper fractions. It really doesn't matter to me. So for this video, I'm going to leave them as mixed numbers. But what I would encourage you to do is on your own time, do the same process where you convert them to improper fractions and just see if you get the same thing. Now, just to remind you, with adding and subtracting, you can leave them as mixed numbers. Multiplication and division, you cannot. Okay, so I'm going to leave them as mixed numbers. There are some little tweaky things that we may have to do, but I think we got this. So to add mixed numbers, you add the whole number part. So we want to take 2 plus 4, which is 6. Okay, and then we've got to do this separate piece over here where we look at 1/6 plus 2/5. Okay. So I've got 1/6 plus 2/5. The issue here is 1/6 and 2/5 don't have a common denominator. So we need to find the LCD. So let's list out multiples. Sorry, I've talked a lot today. So 6 times 1 is 6, times 2 is 12, 3 is 18, 4 is 24, 5 is 30. I like that one, so we're going to stop there. 5 times 1 is 5. Times 2 is 10. times 3 is 15, 4 is 20, 5 is 25, 5 times 6 is 30. So that's our LCD, okay? So I'm going to take 1/6 and rewrite it using 30 as the denominator. Well, what would I multiply 6 by to get 30? 5. So I multiply top and bottom by 5. So we get 5/30. And then I've got 2/5. I want to rewrite it using 30 as the denominator. Okay. Well, 5 times 6 gives me 30, so I need to multiply top and bottom by 6. So I get 12/30. Well, this causes a problem. Okay. So what we have is 6. Well, no, this one will be okay. I was thinking we were going to subtract. This one's okay since we're adding. So what we want to do is we now have our 6. We have our 5/30 plus 12/30. Good thing we're adding and not subtracting because it would be a whole different situation. So now we get 6 and 17/30. No weird simplifying needs to happen here. 17 is prime and it's not a factor of 30. So there you have it. And again, I almost made a mistake because I thought for a second we were subtracting, but we're good. So you add the whole numbers, then you add the fractions and simplify as needed. Okay? Now for this next example, I'm going to set it up a little different because we're subtracting and something weird is going to happen here. So I'm going to write this vertically. A lot of times when I do these problems, I do them vertically instead of horizontally. It just depends. You could do it either way. But for this one in particular, I'm going to leave it, I'm going to rewrite it as vertical. So we have 25 minus 10 2/9. Now, the directions tell us to subtract the whole numbers and then subtract the fractions. Well, I could certainly subtract the whole numbers, but there's nothing to subtract 2/9 from. So we have to borrow. So the only thing we can borrow from is the 25. So I want to borrow 1 from the 25. That's going to make this 25/24. The one that I borrowed, I need to write it in fraction form with the denominator in question, so with the LCD. Since we only have one fraction and its denominator is 9, we're going to take that one that we borrowed and we're going to write it as 9/9. 9 divided by 9 is 1. So let's clean this up just so you can see everything. We've got 24 and 9/9, which is really just a weird, wacky way of writing 25. From that, I want to subtract 10 and 2/9. Well, 9/9 minus 2/9 is just 7/9. And 24 minus 10 is 14. So there you have it. Again, apologies for the oopsie. On part C, for a moment, I thought we were subtracting and it was going to be much more complicated than I originally planned, but we're good. So you can see adding and subtracting with different denominators. It's not necessarily difficult. There's just more steps involved. That's all. So make sure you practice this. I would say for the mixed numbers, if in your own time, try them by converting to improper fractions and see if you can get the same answers. And make sure you practice both methods for finding the LCD. All right. You might find that you're better at one than the other, and that's great. All right. So there you have it. That's it for adding fractions.